All right, guys, I'm gonna start to catch up to you. Let's take a look here. Is this a function?
Yeah.
Totally. Why?
There's no intersecting y values.
For each input, there's one output.
Okay, so yes, you could say for every input, there's only one output. But what's the short way to say that? What's the test? What kind of straight line?
Vertical.
Yeah. Passes the vertical line test, affectionately known as the volt. So every vertical line I could imagine drawing only goes through once. What that literally means is that x value of 2, for example, only has one output. If the function came back on itself, then it would have more than one output. That's no good. That's like saying, where was I on the morning of January 12th? Well, I was in London and I was in Amsterdam. And I'm like, how did you do that? Teach me. Okay. How we do so far? So it is a function because it passes the vertical line test, which means every input has only one output. What's the domain? In general, what's the domain? It's a collection of what? All the inputs that have outputs. Yes? So when I give it to you in a visual, in a graph, which inputs, what's the lowest input that has an output? Yes, -8 is the first x value that has a y value that it goes to. So the domain starts at -8, and where does it stop having outputs? It has continuous outputs until 4. After 4, the poor dude doesn't exist anymore. Oh man. And then what about the range? I just have to do the same idea, except now I go along the y-axis, right? So what's the smallest output I get? -7. And then I get outputs until I hit 2. After that, no good. And why am I putting hard brackets on those? Circles are filled in. So I'm including. If this was an open circle, there would have been some parentheses going on. Yes. Let me stop for a minute. How's that? Is that okay? What is f of -6? Can you plug -6 into something? Not really. I didn't tell you what the function was, but I told you something better. I told you all the answers. So what is f of -6? It must be 2 because that's where they put the output. So another way to look at this question is, what point does the graph go through with an x value of -6? Well, it goes to the point -6, 2, so that output is 2. Bam! Okay, now, pretty sure, I'm almost certain we did this kind of problem. Increasing, decreasing. You guys could trace where this is going up. So if you imagine this is profit, when are we happy? We're kind of happy here. We're sad down here, but at least we're going up. So this is increasing, and then we're like, oh shit, oh shit, oh shit. Okay, right? So where is it increasing? So how do I answer that question? Because you could say it's increasing. No. I have to answer in terms of x. Where is x? What is y? Maybe. So where? So like, if I look at this as profit, 8 months ago we were losing money, but that's when it started to increase. So from -8 until -6, it was increasing. Now here's a really weird question that my other classes had some trouble with. What is it doing at -6? Is it increasing or decreasing?
Still.
It's still. If I throw this pen in the air, at the very top for an instant, it's not going up. It has to not be going up. If it's going up, then it's not the top yet. If it's going down, where's it going down from? Because that's the top. So it must be still for a second. So I don't include the endpoints. So I'm going to say it's it's increasing from -8 to -6. Is it increasing anywhere else? Where does it start to increase again? Yeah, at 1 until what? 4. Cool. And then, of course, where is it decreasing? Starting at -6 until 1. And you can see that's kind of like the part, it only makes sense. That's the only part that the increasing question left out. So that must be where it was decreasing. Right? That's why I didn't include that answer there, because that's where it wasn't increasing. Okay, maybe. What's the local max value? What is the value and where does it happen? It's like if this is profit, what's our locally maximum profit? 2. Like if that was in the thousands, or maybe it is $2, like it's our lemonade stand, right? So our locally maximum value is 2. Why do I call it local maximum? Because it could go higher than that. If that kept going, it could go higher than that, but that would still be a local maximum. Locally is the highest. So that's all a local maximum means. So the local max is 2. Where does it happen? X equal -6. Kick ass. And of course, same idea. Where's the local min? Or I'm sorry, what is the local min? What's the local min value? What's the local min output? What's the lowest output? -7. And where does it happen? Yes, cool. Okay. So in general, where is x values? What is y values? Where is the inputs? What is the outputs? That's not too bad. So when I give you a graph, it's kind of nice because I've already got all the answers shown. You just have to go find them. Number 2, a little worse. I didn't give you any answers. So here's the beautiful thing about domains of functions that I just give you. If I give you a function and you can say in English what has to happen. So for function f, what must be true for it to exist, for it to be a good number? What has to be true? What number, what kind of number do I get out of that in general? I get a fraction, right?
Yeah.
And of course, what can't happen in a fraction?
Y by 0.
Yeah, can't have the bottom be 0. So in English, I would just say the bottom can't be 0. What is the bottom?
X plus 5.
Yeah, so if I say in English for f, the bottom can't be 0. The bottom is x plus 5. Can't be is not equal to 0. And then I solve this. X can't be -5. Now some of you guys figured it out without doing that. But that's kind of like behind the scenes. That's what's going on. I just think, what's got to be true? Write that down mathematically. Solve it. Let me stop for a minute. So what about for function g? If I don't say otherwise, domain is always real numbers. So what makes g stay real? What would make g become imaginary if the inside was negative? So what has to happen to make it stay real? The inside has to be, if making the inside negative makes it become imaginary, and we don't want to let that happen. How do I keep it real? I say the inside has to be at least 0. Yes? If it was less than 0, then bad things happen. So for g, in English I would say inside at least 0. What is the inside?
3x plus 10.
3x plus 10. How do I write at least in math? In mathish? You guys know?
It's the squiggly line.
No. That's approximately.
Oh.
Greater than or equal to 0. How do I solve that? subtract 10, and then divide by 3. So that's the domain of G. It's got to be at least negative 10/3. If you try to plug a number in below negative 10/3, that becomes imaginary. Let's try it. Do y'all agree negative 4 is less than negative 10/3? When I plug a negative 4 in, I get 3 times negative 4 is negative 12 plus 10 is negative 2, and the square root of negative 2 is freakadelic. It's imaginary. Okay. Kick ass. What about h? H is kind of silly. Is there any number I can't square and then add 1 to it?
No.
So what's the domain of h?
Just infinity.
All real numbers. Hey, Bob. Okay. Here's your standard function question, yes?
Yeah.
And what is that telling me to do?
He's not going to plug 4.
Tell me to plug. I almost killed myself. Tell me to plug negative 4 into f, yes? So when I do that, what do you get when you plug a negative 4 on the top?
That would be negative 16 minus 1.
That's crazy. So on the top, I get negative 60 minus 1 is negative 17. And what do I get on the bottom?
You get a 1.
1. So I get negative 17. Schwaba. Now, I can't remember if we saw something like this before, to be really honest with you guys. We did. Sweet. So a better way to look at this is f of 5 divided by g of 5. So if you just take a second, what's f of 5, and then get g of 5, I could just divide those numbers. Yes? So what's f of 5?
Well, that would be 20 minus 1 divided by 5 plus 5.
Yes. So 20 minus 1, 19, divided by 5 plus 5, 10. So that's f of 5. What's g of 5? 3 times 5 is?
15
Plus 10.
Square root of 15 plus 10.
So 15 plus 10 is
25.
25. Square root of 25 is?
5.
5. Holy shit. Okay, now, if I write this exactly the way, it would be 19 tenths divided by 5. How excited are you guys about that? So excited, John. Everything comes out of your mouth. It's amazing. How do I divide fractions?
Cross multiple.
No.
Oh.
You only cross multiply if you have fraction equals fraction. That's the one place in the universe cross multiplication works directly. Does anyone remember how to divide fractions?
How do you make equal terms? So 5 would become
No.
50 over 10.
No. I mean, you sort of could. Sort of. Let me write this a different way because this looks weird as shit, yes? This is 19 tenths divided by 5. How do I change that? 19 tenths divided by 5 becomes 19 tenths times 1/5. There you go. Right? You multiply by the reciprocal. Keep, change, flip is what I keep hearing people say. You guys with me? Do you remember why we do that? Did I show you why we do that? I showed somebody, I can't remember. All right, y'all look very much like you want to know, so I'm going to tell you. What if I had 3/2 divided by 4/5? Yes? You don't have to write any of this down, just watch. You ready? I'm going to make this worse for a moment. 3/2 divided by 4/5. Yes? Why does that suck? Why does that suck?
Well, there's 3 dividing signs.
Is there a giant fraction?
Yes.
And what's inside the fraction? More fractions. Okay, so the reason it sucks is there's fractions inside fractions, yes? It's like, dude, what the shit? It's a Russian nesting doll of fractions. It's fracception. Stop it. What's the best denominator in the universe to have? What number do you wish was on the bottom? 1. Does everybody agree? 1. 1 is the real MVP. If that's on the bottom, I don't even need a bottom. Thank you very much. No fraction, right? How do I make 4/5 become 1? What do I multiply it by? 5/4. I multiply it by its reciprocal, yes? Reciprocal? What am I drinking? I need more of it. or less. I'm gonna try more. Oh yeah. Okay. So if I multiply, you guys agree with me this is one big ass fraction, yes?
Yeah.
This here is one big ass fraction. So if I multiply the bottom by 5/4, I have to multiply the top by 5/4, yes? 5/4? Sure, Ted. What happens on the bottom? It becomes 1, yes? So doesn't this equal this? So that division by this becomes multiplication by its reciprocal. Done. Okay. So how do you divide fractions? You multiply by the reciprocal of the bottom. And what's 19/10 times 1/5?
Isn't that 19/50?
Yes, 19/50. Woo! Okay. Now, does everybody agree that was pretty easy?
Yeah.
You want more of these kind of questions, yes? I want you to realize this is only slightly more difficult. What am I shoving into G? What am I shoving into G for this guy?
The result of H.
Yeah, I'm shoving h of -1. If I only knew what the hell h of -1 was, I could plug that into G, correct? So a lot of times in algebra, we start on the inside and work out. That's exactly what we do here. What is h of -1?
Well, that would be -1 squared plus 2.
What would it be now? Let's see. H of -1 would be -1 squared plus 1. What's -1 squared? 1 plus 1? 2. So now I know what I'm shoving into G. So then I shove it into G. And by the way, that's the technical way to say it. No, it's not. Sorry. What's G of 2? So I wanted G of h of -1. H of -1 is 2. So now I'll replace h of -1 with what it is. And what's G of 2?
That's 3 times 2 plus 10.
That's crazy sauce. 6 plus 10 is,
16.
square root of 16 is,
4.
sweet. Can we stop for a minute? Let these be nice. All function notation is substitution. Whatever you put into it, you put it in. It's kind of silly. Whatever's inside the function, you put it into the function. It's kind of silly. With that in mind, how do I do part E? What function are we messing with in part E? The G function, the rad 3x plus n. What do I replace x with?
E minus 0.
Yes! So functions are so single-minded. You just take what it is and replace x with what's in there. So I'm gonna put this there. And then what can I do in there? Sure. 3b minus 9 plus 10 is
1.
Chabot! Can we stop for a minute? I really want you guys to see, because people start letting this tell them, oh, no. Whatever that's in there, you just shove it, you just put it in there, and then you do as much as you can. Why can't I get a number out? Because there's a freaking B in there. I don't know what that is. What is this telling me to put into what? What am I putting into what? I'm putting h of x into G. Well, what's h of x?
X squared plus 1.
So I'm putting x squared plus 1 into G. So I write G. G is 3 times stuff plus 10. And what am I putting into it? X squared plus 1. I need you to see. We keep doing the same thing over and over and over and over and over. If it's a number, I can do more. If it's a letter thing, I can simplify a bit, right? So if I distribute, and then I can put my like terms together. Okay. How are we doing with that? It's pretty much as far as we got. Now, a very neat thing's gonna happen right now. I am not feeling well. I'm feeling weird. So we're gonna call it a day. We're gonna call it a day. because I'm the teacher, I can do that. I'll have the quiz graded by Tuesday. I'm not gonna try to think of the next, we'll talk about the next quiz on Tuesday. It might be Wednesday, so just be ready. Let me know if you have any questions, otherwise, I'm gonna go home and lay down. Okay. Oh, don't forget, whose ID? Christian, don't forget.
Yeah.
Okay.